Hey guys, welcome back to Rocket Gyan, my fellow space tubers. And today we are here to witness another launch of August, and this time it is Vega, which is going to the space, carrying 5 satellites to the orbit. And again, this is a stream which is done by Arianespace, and how does Arianespace to conduct its stream. So don't expect much, I would say, because again the title for their stream is same like the previous one, the Road to Space. I don't mind actually them speaking, commentating and discussing the informations about rockets and orbits. Okay, so robots, new word which is if you want to combine both of them. I like it. Okay. Yeah, so I was saying, let's hope we get some rocket pictures, and let's get into this. So before doing that, how are you all guys? How are you? Hi, Clemens. Hi, Wildflower. Hi, Scott. Hi, Bill. Hi, Rohan. And hi, everyone. What is the flight path? We will discuss everything. Don't worry about it. Okay, looking good here. Everything is looking great. Now let's just discuss about this rocket. So talking about this Vega rocket, this is a light launcher, which means it comes between the payload capacity. You can see that 1500 kg. So it's like small to medium launcher, and it has a 3 to 4 per year launch rate, and it is all solid rocket to the orbit. Disregarding the last stage. So the first stage, you can see this is a solid rocket motor. It is the most powerful stage in this rocket, which is obvious also. Around a thrust of around 3015 kilonewtons, and this is a solid rocket motor, and it has HTPB as its propellant, and it's burned for around 113 seconds and jettisoned at 58 kilometers. So this ports the first stage ensures this rocket gets out of the thickest part of the atmosphere, and around 58 kilometer it is like no atmosphere at all. And then the other stages, the second and the third stage, can be vacuum optimized with their nozzles being stretched out. So that is the case, and you can see here this there are some small um, motors attached to it. These are the separation system motors attached, which means whenever this rocket separate, this fires. And it's a retro rockets. So whenever the first stage separates, this fires, so that the separation increases. And now the second stage, this is a Firo 23 second stage, and the second and the third stage are almost similar. And it can produce a maximum thrust of 1.120 kilonewtons and burn for 78 seconds. So you can see now the efficiency of the rockets are increasing, the burn time are increasing. And the propellant is HTPB again. HTPB was used in the first stage also, the second stage also, you can see here. And yes, that is pretty much about it. And then the third stage also is the solid rocket motor, and you can see is the smallest stage of all of them. It's like 4.12 meters long only, produces a thrust of 317 kilonewtons, but burns for 120 seconds. The smallest one, but burns for longer. And yes, that's what you actually want when you are in space. You want the last stage to burn for most amount of time. So guys, in rockets we have like a trade-off in which we play. Okay, so if we want higher thrust, then we compromise ISP. If you want a higher ISP, then we compromise thrust. So as you can see here, as the burn time increases, which you can technically say that is the ISP of the rocket, the thrust is decreasing. Here you can see this is the longest burning stage, and the thrust is only 317 kilonewtons. So you have this trade-off which they people have to play with. And when it is you are talking about the upper stages, you want them to run burn for a longer time. If you can compromise with the thrust, but you want them to burn for a longer time, because yeah, most of the time what happens is, that's the final stage. You are like, for this stage is supposed to put the satellites into the orbit. Okay, that's what it is supposed to do. The last stage, the fourth stage, is basically a velocity trimming module. And I mean, it has to, it is there to improve the accuracy, as well as it is a restartable stage, so you can technically say it supports multiple payloads. So that is a different function, but till the time it is on the third stage, it has to go into the orbit. And when we come, talk about the solid rocket motors, uh, we they tend to go fast, vertically fast and then horizontally fast when it comes to solid, because they have a lot of thrust. So yes, that is one thing. Now, this is the AVUM module, which is nothing but the attitude and the vernier upper module. And this is a bipropellant main propulsion system, which means it runs on hydrazine and N2O as its fuel. And it has the other, attitude control systems for roll and reaction control. You can see it has around 577 kg of propellant of UDMH N2O4. RD869 is its engine, providing 2.45 kilonewtons of thrust. Again, you are playing with the thrust here. You can see the thrust is so less, but again, you are getting um, the burn time out of it. Yeah. Okay. I think that is the overview of the rocket. Just a sec. Let me. Looking good. Okay. I can't wait for the Qantas to launch their French rocket. Yep. I'm enjoying early breakfast. Uh, I hear it's like when I wake up, it was 5 a.m. So you can say I just did my breakfast and it was super early. Hi, Ayan, how are you? Um, what does having a bigger rocket nozzle do exactly? Why can't they just be the same size? Okay, so for the okay, let me just have a exploded view of the rocket, not the rocket which has been exploded, but the exploded view of the rocket. Will make you better understand the sections of it. Here you can see this is the first stage, which is a solid rocket motor. Here you can see uh, the core here. This is the nozzle, then the second stage and the third stage, which have a slightly bigger nozzle. You can see here the stretched out nozzle for the second and the third stage, obviously, which is supposed to do like this. And you can see here, why am I saying it is a stretched out one. If you compare this part, I don't know whether if it is scaled out or not, but the black part of it for the second stage is not that long, but for the third stage it is that long. So it's like kind of stretched out for the third, and then the fourth AVUM stage. Okay, talking about why do we have a stretched out nozzle. So you want, technically, what does the rocket do when it flies into space, or whenever it is operating at thrust? So they have two types of thrust. First of all, the obviously the rocket thrust, which is providing the thrust to the rocket. And then there is one more type of thrust known as pressure thrust, and this pressure thrust can play against you or for you. Okay. Whenever you see the rocket engine, like in what should I say, uh, pressure thrust. Okay, how do I define the pressure thrust is nothing but the thrust which can interfere with your rocket thrust. It can negate some of that thrust. And how does it do that? When the pressure outside of the rocket does not matches the pressure of the fuel coming out of the rocket. Okay, so when they both don't match, they basically interfere. You can say they basically interfere with the stream of the rocket plume going out of the nozzle, which interferes, which decreases or increases the thrust. Okay, so that's how that happens. So like for example, the Saturn V initially had a negative pressure thrust, and that is why you can say, I mean, that negative thrust was not too much, but again it was there. So there was some negative thrust, but obviously it was Saturn V, so it was able to lift itself. But that was one thing to notice. And when you the ideal situation for the pressure thrust and the rocket thrust, you know, uh, be at best is when the pressure outside is equal to the pressure of the plume coming, outside of the rocket. Means the atmospheric pressure, the surrounding pressure, as well as the rocket plume pressure. So when they both matches, then you have the ideal performance of the rocket. So when in vacuum, what you are doing? Basically, you are increasing the rocket nozzle's size, and when the rocket nozzle size increases, the pressure actually drops. So you can kind of say the area increases and the pressure decreases. The conversely, inversely proportional. So when you are increasing the nozzle size, you are decreasing the pressure here, which means you are technically making the pressure of the plumes coming out of the rocket as zero, because in vacuum it's kind of near to zero. So you ideally want that, but obviously you can't achieve zero, so you try to expand as much as possible, so as to achieve that zero pressure. Also, you can say that we can have the extended nozzle on the you know the admins operating in atmosphere also, but the pressure thrust would be so large that it will interfere with the rocket thrust, and maybe you know uh, damage the nozzle because of the thrust, or the atmospheric thrust, interfering with the plume. So I guess I have made some sense there. And there is some other way also people like to, uh, explain this term by having the extended nozzle. They are actually increasing the velocity of the plumes coming out of it, exhaust coming out, and hence you can get more efficiency and thrust in. Okay, moving on. Then the next thing which I would like you to see is the first stage, but a bit of a technical view of the first stage. Here you can see we have some actuators on it which provides the gimbal, and this gimbal is controlled by the electromechanical actuator. So it is not mechanical actuators totally, it is electro actuators. And uh, which means the batteries are installed there and the motors comes into play to gimbal this first stage, which has like a 6 degree of gimbal range. So that is one thing, first stage. And you can see here the 6 retro thrusters marked here. And yeah, that's what we get out of this. Now moving on to the second stage. For the second stage also, you can see we can even see the batteries out here. The second stage, a TVC IPDO battery, the first stage battery, which means the second stage carries both the batteries for the first and the second stage, as well as the second stage also has the electromechanical actuators, which means they have the motors coming, the controlling the gimbal for this rocket. Okay, then the second, they have the second stage safety system also, which means nothing but the flight termination system. So the in the second stage, basically the flight termination system is installed. And yep, that is about it. And then the third stage with the biggest nozzle, again the actual electromechanical actuator. We can see the batteries also. And here you will see some the avionics coming into play. The third stage, pyro circuit is what they use for the ignition of solid rocket motor. And yes, that is pretty much about it. And moving on to the fourth stage, which is the AVUM stage. This is an AVUM stage, and this runs on, these are the tanks also. Here you can see the UDMH tanks. Here are the UDMH tanks, and then these are the N2O tanks. If you can see, these, work to provide the thrust for the single main engine, the RD860 engine, producing 2.4 kilonewtons of thrust. And then they have this 60 sorry, six attitude control system, six thrusters basically for attitude control system. Avionics are installed here, and this engine is restartable for multiple times. And we have a flight control, telemetry, power system. Most of these um, critical elements are present in the top stage, which makes sense because you're ditching all the stages. The last stage which you have uh, in you know, space is what you want to give the most brain, most power, most communication. So yes, that is what we have here. Okay, now moving on to the payloads. The payloads, first of all, this payload. This is an Earth observation satellite from um, the Pleiades Neo constellation, if I am correctly pronouncing it. This constellation basically consists of four satellites in two different orbits, and the main purpose is to image the satellite at image the Earth at high resolution at around 30 centimeter per pixel, which is very high resolution for a satellite. And this four satellite constellation is designed to provide near real time imaging of the Earth, and thanks to the European data relay system, which helps the satellite to relay the data and provide near real time image of the Earth. And so there are like uh, um, four satellites, if I'm not wrong, or six satellites. This is the fourth one which is going. Okay. Now, moving on to the next payload. This is an exciting one, the LED SAT. Is named as LED SAT because, first of all, this is, developed by by students. This CubeSat is developed by students, and it is to demonstrate the ability to optically track a small set while it is not illuminated by the sun. Right now, the satellite which are illuminated by the sun are captured by the ground telescope to basically, you can say, mark its orbit where it is going on. And that's how they track the satellites. And if a satellite does not have any illumination system, I mean, the satellite is not the sun, and if it has some illumination, I mean, if LEDs are working on it, then this satellite can be used to, you can say, track it. So that technology will be tested on this satellite. So this has a mass of 1 kilogram, and it was selected for ESA's fly or satellite program in way back in 20. So it's a very cool one. It does not have any propulsion place, but solar panels and batteries are obviously there. But it is kind of demonstrating a new technology in space, so it will be super helpful for us. Moving on to the next one, real quick. The other one is the rad cube. This is a cosmic radiation. This is basically used to give the information about the space weather. This is a weather satellite, uh, and this has a constellation. This satellite will monitor the cosmic radiation space weather in near real time, and it also does not have any propulsion. Now this one is a Bro 4 satellite. uh, this reconnaissance orbiter constellation is a constellation spectrum monitoring and electromagnetic intelligence survey signal intelligence satellite. So basically this satellite is used to monitor the naval space, and it will survey the maritime activity and will be used to help stop the illegal fishing and other environmentally unfriendly behavior in the ocean, in the sea. So you can basically track the boats coming in the ocean which should not be there. And it is a good one because it will uh, you know uh, s- get us to a halt for the illegal fishing, as well as maybe track some pirates also, pirate ships. We don't know. It's a very cool satellite going to the space. Next one is the Mu Hat Sat, if I'm not. This is in collaboration between ESA and Italian Space Agency, and CITIOL, if I'm not wrong. Okay, this is basically a satellite which is used to test the Hall effect thruster, which means a ion thruster for a CubeSat. this will be game changing because right now the CubeSats does not normally have any propulsion systems because of its size, obviously. Now if they can, you know, make a proper propulsion system, which will be demonstrating for this is a CubeSat only, and if they can demonstrate a propulsion system for this one, then the CubeSat will can have a longer lifetime, as well as can control its orbit, maybe deorbit also, so will not clutter in space. So that is okay. Now talking about the flight sequence, let's have a look at the flight sequence real quick. The mission duration 1 hour 44 minutes. This is how it will look like. It's going to a sun synchronous orbit, which means a polar orbit, and you can say it's like kind of a circular orbit. And the flight sequence is kind of, you know, how the things work here. So I don't think so I need to discuss about this. And I think I should move on to the launch webcast if I. Oh, thank you so much, Null Unit. Been a while since I have been able to catch a live stream. Thank you so much, Null Unit, for that 25. I just missed that. Really appreciate it, and thank you so much, Clemens West, for the 499. Keep up the great work, Rocket Gyan. Thanks for all the streaming of launches. You guys are great. I can't thank you enough. Okay, so okay, yeah, we have some time, 3 minutes or so. Cool. And guys, I just can't thank you enough. Thank you so much for all your support and everything, because your support is what this channel thrives on. Uh, Otherwise, you know, this channel is dead in a day or two. I am telling you that, because you can see that right now the most of the majority content on this channel is live streams, and live stream sucks for revenue. Your you know, support and love and you know, donations is what actually makes this channel possible. So thank you so much for all of you and working together and you know, making it possible. I try to do my best whenever possible to give you the information, as making, you know, breaking it down to bits and pieces and explaining you. I may not be a big, you know, a very good explainer of things, I don't know, but I try to do my best. So so much all for now. Does this have a cameras on board? Well, that's a good question. They recently purchased, Arianespace recently purchased some cameras. Okay, let's just have a look at this tree. To that we can wait for them. Just oops. Fine. Yeah, so I was saying that they recently purchased some rocket cameras. They didn't have, I think they didn't have one, that's why they purchased. But I don't know whether they will, you know, demonstrate them on this flight or not, but they have purchased some onboard cameras. So we'll have to wait and see how things will look. Okay, is there anything else that do I need to talk about? And I do need to talk about, okay, that I'll talk about later during the after this launch. Uh, Flying in a general direction, and this one has some propulsion. Yes, this one has some propulsion, which means it can adjust its orbit. It can definitely, you know, do the station keeping at least, because the ion thruster, as you know, it has a very high ISP, around 1600 seconds, which means you can say it has a higher mileage. You can kind of say that 1 liter of fuel gives it a burn time of 1600 second, and for chemical rockets it is way lesser than that. The most efficient one is like 460 seconds or so. So it's like a very efficient one. And that Hall effect thruster is which means an ion thruster only, and it is a design for CubeSat, so it will be able to do the station keeping, the orbit itself, and maybe change the orbit also. We never know, because since it's just a small CubeSat, you don't need a large fuel, you don't need a higher thrust ion engine. You can just go with it. Okay, so yes. And oh, thank you so much again, Leonid. You just rock. I don't know. I mean, I can't just thank you enough. Great coverage as always. Really enjoy your live stream. Thank you so much. And I hope I can, you know, entertain you and provide you knowledge at the same time on this stream. So we do. I didn't do the Kerbal version of this just because I didn't have the flights timelines for this launch. It was very weird that the Arianespace didn't release the flight timeline. Had the flight sequence, not the flight timeline. So that was a bit of shame. Okay.
A big welcome to you. You're joining us live at the Guiana Space Center for the 7th launch this year.
Wow, this is a
Hot
very
and
bad
humid night
quality.
on the edge of the Amazon rainforest.
I'm running it at HD quality only, but right
French
now
Guiana.
the quality.
I'm Katie Haswell, and our interpreters are Mark Fermat and Christopher Jack. They're going to be translating me for our French-speaking viewers tonight. And we are traveling on board a Vega Rocket. She is flight number VV19. There she is, standing tall on the pad, about 30 meters tall, in fact, and weighing in at around 140 tons. She's got 5 satellites on board waiting to start their journey, tucked up inside the top of the launcher. And our main passenger tonight is Pléiades Neo for Airbus Defence and Space Intelligence, or Pléiades as some of us Brits and Americans call it. It's the second satellite in their Pléiades Neo constellation. We launched the first one 4 months ago, and we're launching the next 2 on Vega C. And I have to say, these are literally groundbreaking satellites. They're going to provide crystal clear photographs of our planet with a resolution of up to 30 centimeters, and take it from me, that's very, very high res. And inside the fairing alongside Pléiades Neo, we have 4 other auxiliary passengers, all microsatellites actually, riding along as a piggyback. They are Bro4, for the European company Unseen Labs. And then we have 3 satellites for the European Space Agency. They are Sunstorm, Fly My Satellite LEDSat, and RadCube.
Kind of, they have improved the coverage. Right now, we are just seeing the rocket, which we should be doing that. So I guess they have, taken our review. But again,
up on the top right-hand side of your screen. At this point before the launch, all eyes are on what we call the status panels. Here they are, right-hand side of the screen there.
everything is green right now.
Basically the status of all the systems across the base which send their go, no-go status, and they're up here on these panels. So they're showing us 3 main systems primarily. We've got the range, which is basically the base, and the tracking stations dotted along the flight path, and also the rocket and the status of the pads. And then of course at the bottom we've got Meteo, which is the weather. We've had the last weather forecast about 10 minutes ago, and that was all green, so that's good to know.
And thank you so much, Sean, for that 5. Hey, Bird, love your channel. Keep up the great work and good luck with school. Thank you so much for your wishes, and appreciate your love and support. Thank you so much for everything.
Going to be on the phones, no doubt, throughout the flight.
So I guess they have taken our review critically the last time, which we, all over the space community, they had to, listen to all our blabber and everything. I guess they have taken our review, and now we are seeing the rocket, but they have, I don't know, but, I don't think so. They have improved the coverage, I guess. I don't know why. The quality of the cameras which we were seeing were not HD at first, but right now they are improving. Let's hope we are good for the launch today.
The
Let's
fishbowl is
see,
made of
Solex,
very
if
tiny
if
glass
they
to
have
protect
not
everybody. And it's
if they have
actually
installed any
quite
cameras
loud.
on the
If you
rocket.
knock on
We'll
it
have to
from
wait and see.
outside, the people inside can't hear what's going on. Many of these teams have actually been working in French Guiana now for some months preparing for today, and it's called the launch campaign. This campaign started on the 22nd of June with preparations on the launcher. The auxiliary passengers were prepared primarily partly in the Czech Republic. There are operational teams for our satellites here. And also in French Guiana. And then the work had to start on the satellite itself.
Minus
And
450.
here we've got the boards that everybody is looking at. You can see the status panels on the left-hand side there, showing us those status. We've got the time, the countdown times there on the left-hand side as well. Images of the launch vehicle on the pad. And then we're looking at trajectory, etc.
Is it me only or the video is a
Vega
bit
standing
blurry?
tall there. You can see all the lightning towers around the outside. A couple of other key people here. This is the range operations manager.
There you go. Let's yes, I guess he has just approved the range.
And he's just announced the beginning of the synchronized sequence, or the automated sequence, the last 4 minutes of the final countdown.
Hi,
Our
Iron Clue
range
Gaming.
operations manager is Jean-Luc Voyer, and he's the one, he actually coordinates the launch-based systems during the final countdown, and he also calls out all the major events during the flight, so listen out for him. I'll be translating him throughout the flight, and he's going to be telling us what's going on and keeping us up to speed. In fact, everybody across the whole base will be listening to him, and indeed the men and women in the tracking stations, even in Australia.
We are T minus 3 minutes until the launch. Everything is green right now, and we are with the automated launch sequence has begun on this rocket, which means you can say that the countdown is being controlled by the rocket. The rocket is doing its internal checks of all the systems, and everything is looking good. The range is green, everything is green basically, and we are just waiting for this beauty to lift off from the pad. And you can say that this rocket is a solid fuel rocket, and it has enormous thrust to weight ratio, so don't blink your eyes. You will miss out on the good show for today. We are coming in hot today, and T minus 2 minutes left only. So let's see what do we have in store for us.
The teams
Hi
from
Don, welcome
Arianespace,
to the
who are the
stream.
link with the customer.
Yes guys, if you like the stream, you can hit that like button, and whoa, thank you so much. Unit, you are great. Thank you so
So I was
much
saying the feed
for
lines,
all
when we get
your
another look at the
support
launcher,
and
you
love,
can see
and
the
I
feed
can't
lines
thank you
which
enough.
carry the electricity and communications with the
Thank you
satellites.
so much, Null Unit.
We call those the umbilical lines, and they get disconnected just before the launch. The final countdown started just over 6 hours ago.
So let's right now just view the
mobile
launch,
gantry was
and
removed
let's
just
hope
about 4
everything
hours
is
ago.
good. Right now people are looking
Now
calm
we're
and
coming up
steady.
to the final minute.
T minus 1 minute and 12 seconds left. Okay guys, minute left. We, you know, we didn't even okay, 1 minute.
Just announced that we are 1 minute to launch. We're delivering Pléiades Neo for Airbus Defence and Space, along with Bro 4 for Unseen Labs, Sunstorm, LEDSAT and RadCube for the European Space Agency. I'm going to turn my mic off now and give our very best wishes to all the teams. Let's watch.
Finally, we are T minus 30 seconds to launch, guys. Everything looking good. This rocket will be phenomenal during the launch. So T minus 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8,
9, 8, 7, 6, 5, 4, 3, 2, unité, top.
mission. Whoa!
V80 et décollage VV19.
Wow. That was epic. Please, 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 can you give us this? Yes. That looked phenomenal in the sky. You can right now see
La propulsion est nominale.
they have improved the coverage. And wow. Everything is nominal right now. The first stage is performing as expected. It is pitching over, as you can see right now. The first stage will burn out when the altitude is
What
around
a
58
sight.
kilometers.
They are off. Vega streaking across the night sky, lighting up the skies over the spaceport, over the Amazon rainforest. Our passengers have started their journey. Pléiades Neo, Broforce, Sunstorm, Leadsat and Radcube are on their way.
We can see the
It's a huge moment for everybody who's
plume
involved.
expanding
It must
right
be
now.
quite something watching your babies lift off from the pad.
Yes.
Getting a great view here. We can still see the launcher 1 minute and 25 seconds after liftoff. We're looking here at the...
Trajectoire est nominale.
He's telling us that everything's going according to plan. We were looking back there at the main stage, or the first stage, the P80, the engine of the P80, it's known as, burning. We tucked in behind the clouds for a bit, but we came out again, so we got a
now
great
we
view.
have the coverage.
6, 7, 8 kilometers, and we're getting faster and faster.
So right now you can see the telemetry is looking good. We are going on that red line, and the velocity is around 0.7 kilometers and per second. The altitude you have to see that 171 kilometers. So it is well above the atmosphere right now. And the improvements for the second stage is that it has to perform in vacuum. So yes, that is the thing.
Good view there of our launcher on the right-hand side, and on the bottom left,
Although we don't have the apoapsis and periapsis view, but it's looking great right now, as it is following the trajectory. It's not like what we saw in ISRO's. So let's hope everything is good.
take a look at what we call the fairing.
And thank you so much for that 20, so Alex. Really appreciate it, man. Thank you so much for all your love and support. And I was just, want you to enjoy the launch first, and that's why at that time I didn't announce your name. So everything is looking good.
Nominal. We're climbing. Look at the altitude, bottom right of your screen, 127 kilometers, and climbing.
Séparation Z23.
There you
And
go.
we have
The
separation there of the
separation.
Z23 and beginning of the roll motion.
And this is necessary to stabilize the rocket, because right now this solid one, okay,
Z9.
Switch the engine on of the
and we
Z9,
have
De la coiffe.
the Z9
the
engine.
fairing
And
separation.
we have separated the fairing. Did you see how it came away? All perfectly planned.
Now
We
this
don't need the
one
fairing anymore.
will burn for
So
120 seconds, which means around 2 minutes for the solid rocket motor. So it is a big one.
149 kilometers
Big
high.
burn.
It means we crossed the threshold into space about 50 kilometers ago. And look at that, you can see our satellite
Et nominale.
for the first time, the gold structure on the right-hand side. That is Pléiades Neo. All folded up right now, all nice and neatly packed together, but later, after it's released, It'll unfold its wings, just like a butterfly coming out of its chrysalis.
Wow, the animations look sick. I
And
must say
then
that.
to the left of
Wow.
it is the conical structure. That was the payload adapter.
And there
Look,
you
you can
can
see
see.
where we lifted off. We came from the launch pad at the CSG, the Guiana Space Center in French Guiana on the northeastern coast of South America. The tracking station there is Galileo, and we're heading towards the next tracking station in Bermuda in the Caribbean. And there you get a better view there of the conical payload adapter. And then to the left of that is the big tank burning its fuel.
Everything is nominal.
So
Last time I remember that there was some malfunction in the AVUM stage. Last time, the last launch was successful. So, oh, whoa, 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 whoa.
Oh, wow, look at that's really, really interesting watching how these maneuvers happen in space. And
So
these
this was
images are the CGI images which have been
this was as
very
planned, right?
carefully planned, and all the information has been put into the
Oh,
computer and reproduced these really sensational graphics. So the sun-synchronous orbit is very
that
useful
was
for
planned.
satellites which are Earth observation satellites, because it allows them to monitor the same place at the same time every day. So, for example, our
I
satellite might
was
fly
having flashbacks for the GSLV Mark II launch after seeing that maneuver. That was pretty intense one.
The launch is operating remotely,
There you go.
and there we go,
Separation.
separation
We'll
of
coast for a bit, I
the
guess.
final stage there, which means we're now really entering the next phase of our flight. The Z9, the third stage, has been jettisoned. And this means that the propulsion phase of the launch is now over.
It is going down intentionally. Yes, the GSLV Mark II was not supposed to go down, but here it was supposed to go down intentionally. But that maneuver which it performed, that was truly intense. I must say that. And it didn't broke because of this. Wow.
Right, we've picked up the signal at the Bermuda tracking station. Now, look at this. These boxes, which are attached to the payload adapter, are called deployers, and inside those are our CubeSats. Our CubeSats are made of 10-centimeter cubes, so they fit very, very neatly inside there. It's really quite beautifully planned. And later, once they get released, they're going to pop out of those boxes, just like jack-in-the-boxes. And they'll shoot out into space. So we're looking at the AVUM, or the AVUM upper stage. The white disk is where we have the vehicle equipment bay with the avionics, the onboard computer, that sort of thing, and obviously the propulsion. Everything's going well.
We have the burn
And
here.
the upper stage has switched on its engine, that's confirmed.
So that is good there.
So this is really the next stage of the flight now, because the AVUM upper stage is going to transport our satellites to their destinations in space. And that is a very, very important job, because each satellite has to be positioned in a very precise orientation and in a very precise location. He's telling us that the trajectory is nominal. And the AVUM upper stage, it actually stands for Attitude Vernier Upper Module. I call it AVUM because I'm a Brit, but it is often known as well as AVUM. He says the pilotage, the piloting, is calm. And it's a very useful piece of kit, because it gives us huge flexibility and allows us to perform all kinds of very complex missions. It means that Vega can launch all kinds of different satellites, and it's particularly suited to these kinds of Earth observation missions for governments, space agencies, and of course today, private companies. Bit of technical information. The AVUM is 1.5 meters wide. It weighs approximately 1.3 tons. It's made of aluminium
La propulsion est nominale.
with titanium tanks, and it burns liquid propellant. Like many upper stages, it can switch its engine on and off. And it's the smart stage, it's the one with the brain, it's the clever bit. It's housing the computer, as I mentioned, the avionics and that sort of thing. And then attached to it is the conical structure, the payload adapter, which then allows us to attach our upper passenger, the Pléiades Neo main passenger.
Okay, so let's have some take some questions chat. So we have one question from Yehuda. He says, why does the rocket engine look small? Should it not be bigger than the other rocket engines because it's in space? Yes, you have taken my teaching to a good level and asked a good question, I must say that.
And if it does deviate, it can correct itself.
Okay.
Come back to the correct trajectory. So it's pretty clever stuff.
Acquisition de la télémesure pour la station de Saint-Hubert.
And we've picked up the signal now at the next tracking station. It's in Saint-Hubert or Saint-Hubert, and that is in Quebec in Canada, just outside
Okay.
Montreal.
So let me just answer that question for you. So basically, that engine, you are absolutely right, that should have a bigger nozzle. It is a bigger nozzle for what that engine is. Okay, it is just a small engine. It produces a thrust of around 2.4 kilonewtons. Okay, so it is not pulling, throwing those gases out at massive speeds for what we have for other rockets, right? So that's why if you have a smaller nozzle also for this one, you can go with it, because you are not actually having a very large engine, and you are having a small engine. So for a smaller engine, that nozzle is relatively longer. Okay, we are not able to see in the animation, but it's just a 2.4 kilonewton engine, and we are having that a bigger nozzle only, but it's just that for a bigger engine we have a bigger nozzle, and when you scale down that engine, the engine will also scale down, the engine part will also scale down, and the nozzle part will also scale down. So that is how those things work. So the space, it is in space, it is having that bigger nozzle, but the engine part is also small, so you can see that it kind of is scaled down version of what we expect for other engines. I hope I have answered your question, and thank you so much, Francois, if for that Canadian 3099. Really, really appreciate it, man. Okay. Why there are missing mission controllers? I don't think so. They are missing any. I guess you are talking about why there's so less people in the stream. I guess that is because of the COVID situation, which we all know. Maybe there is some. I hope that is not the case, or maybe there is some spread out there, or a breakout. Yeah.
Tiny satellites orbiting our planet and delivering high-speed broadband, keeping us all connected everywhere on Earth. It doesn't matter where you will be connected, and not just you, but your stuff as well, your things. All of these small satellites need to be launched into space, and that's where Arianespace comes in, because they have a lot of choice for different types of satellites, and they've deployed rideshare and piggyback options too, like today. Today we're on a piggyback configuration.
La propulsion est nominale.
All going well. And it just shows how Arianespace can adapt to their customers the very best solutions for their launch, because of course each launch is different.
Yes, looking.
Vega and Vega C are particularly well suited to these kinds of missions, as I mentioned earlier, and primarily because Vega is very versatile and light, and she's small and she's flexible, and despite her diminutive size, she can carry lots of satellites at once. It's a fact. Good things come in small packages.
She's supposed to talk, obviously, because otherwise the stream will become boring. I guess how she will pull out this stream, because it will be of like 1 hour and some 14 minutes or so. let's see how this will pan out, but let's right now everything is looking good. And talking about that pitch maneuver, can anyone tell me why did why did it perform that pitch maneuver, if you can? Because uh, that was a pretty drastic maneuver, and it pitched down rather than pitching up. Can you tell me why? And the hint is that something related to that I mentioned in the stream only previously.
Engineers have attached the CubeSats directly onto the payload adapter. So we're traveling light today, and that's actually quite beneficial because it's allowed us to move our flight path 15 degrees to the right, 15 degrees east, rather, to the right. Just shows. And that's actually good because it's been able to our chances of launching on time. And the reason that works is because sometimes high altitude winds can delay a launch, but by moving our trajectory 15 degrees to the east, we've been able to take advantage of those winds.
Wow.
So yeah, it's all
Propulsion est nominale.
very clever stuff. Yes, the propulsion's nominal, and that's good to hear. Now the AVUM upper
Première
stage.
inspection de l'AVUM.
And he's confirmed the upper stage has actually switched its engine off. That's what it looks like up there. Right, so we are now beginning the orientation. AVUM is putting
Collecteur est
itself
nominal.
into the separation orientation, I believe. Getting itself into the correct position so that it can separate the satellite later. Here we go. It's moving around into position. We've travelled just under 6,000 kilometres. If you were to draw a line along the Earth from the launch pad. And we're now starting, well, we've started the ballistic phase, the first ballistic phase. Ballistic means that we're travelling without the engine, we're coasting without the engine. And we're also, if you take a look at the passenger, you can see we are twisting. We're actually, well, we're in the barbecue phase now. The barbecue maneuver is the technical term, believe it or not, yes? I love how they call it that. Lots of other very technical terms, but the barbecue is definitely my favourite. We're twisting as if on a spit. We're doing that to keep the temperatures homogeneous and even because, of course, when you're facing the sun, it's very hot, and when you're facing space, it's very cold. And
Yeah, I
if you're
will
interested,
answer
we're
the
twisting
question
at a
which I
roll rate
asked.
of 2 degrees per second.
Right.
Trajectoire est nominale.
And the trajectory is nominal. Shortly we're going to be going out of the range of the tracking stations. That's perfectly normal and it's all part of the plan. I'll let you know when the range operations manager announces that. But we'll be out of touch with the launcher for just over half an hour. We won't be getting any telemetry data from the launcher during that time. And then when we get back into range, the launcher's going to store, AVUM will store up all the information accumulated during that half an hour or so. And then when we get back into the range of the next tracking station, that's New Norcia down south in Australia, then there'll be a big download of information to that tracking station so that the teams here at the Guiana Space Centre can then find out what's happening to the launcher in real time and also analyze the information afterwards.
Okay, so I guess now I can answer it. Um, Many people have tried to guess the answer, so let me just read that out for you. To attain the correct altitude and speed, okay, to assume it was pitching so that SRB doesn't overdo the burn. Okay. I would guess it was to circularize the orbit a bit. Okay, the synthetic effect of the CGI. This can also happen. Downhill to pick up the speed to give the satellite the orbit that was planned. Very well. Which maneuver mentioned on page 32. Okay. How many engines? Okay, I'll tell you about that. So let me just tell you why it does the pitch that means that maneuver initially. So yes, everything is done according to the plan, which means it according to what orbit it has to achieve. But typically, I mentioned in the stream only previously that this is an all SRB rocket. And this, since it is an all SRB rocket, which means it has a higher thrust. So that's why the typical rocket profile for this, rocket is. Okay, so yeah, the typical rocket profile for this rocket is very steep rather than shallow. So you can see that it goes vertically more rather than horizontally. So it attains more altitude in a shorter duration of time, which it has to. So and hence to counter that at that point of time and gain speed for the AVUM, because as you know, the AVUM is not very well equipped with high thrust. So if you are performing in a with the AVUM in a what do you say, in a maneuver which gives you more gravity losses, that will cost you the thrust, as well as you may not be able to circularize also. So by having this profile in which it goes straight up, not straight up exactly, but more straight up rather than horizontal. So what you are doing is you are giving the womb upper stage that uh, that extra speed which it can have, by because it then starts fall down and then again start pitching going up. So by doing that, you are minimizing the gravity losses, because at that point of time when it is slightly going down and then going up, at that position, that point, it is uh, you can say that it has totally achieved the orbit at that point of time when it is transitioning from going down to going up. So at that point of time it is actually achieving the orbit, and when once the orbit is achieved, now you don't have to worry about the gravity losses at all, because I won't say that technically the gravity is not present, but the gravitational effect is not present, and hence you don't need to worry about the gravity losses, and you can go with the 2.4 kilonewton thrust. So yes, everything is very very smart when it comes to rocket designing and the flight profile. Every rocket is unique, every profile is unique, and every mission is unique, and that's why the launch of every mission is unique, and that's why we watch it. Wow. I am also surprised that I just thought about that reason right now only, and it does make sense. So yes, that is the reason. You can say that. That it goes downhill to pick up the speed as well, since the AVUM stage does not have that enough thrust initially, and once it is in the orbit, you don't have to worry about the gravity losses. So, and that is the reason why whenever we want to escape the Earth, when we don't want to achieve the orbit of the Earth and we want to escape, let's go, I mean, when we are going to Mars or when we are going to Moon, then we just don't go straight up and up and up till we reach the Moon or the Mars. Okay, we achieve the orbit and then we throw ourselves out in the direction where we want. Uh, just because when we achieve the orbit, we are then not dealing with the gravity losses, which means we are not fighting the gravity at that point of time. We are not fighting the gravity with the engine. So that is the case, basically. That is the reason why we achieve the orbit rather than just going straight up to the moon or to the Mars or whatever. We achieve the orbit and then we go out. We are thrown out of the Earth's sphere of influence with the help of all the maneuvers we perform. Of time, we are not dealing with gravity losses. So yes, and you can kind of say that even a rocket which can achieve the orbit will not be able to escape the Earth, I guess. What should I say? Uh, yes, kind of, you can say the escape the Earth, just because it is going straight up and then not going horizontally. Okay, let me just frame it this way: a rocket which can escape the Earth, okay, which is designed to escape the Earth or like go to the Mars, like Atlas 5 with Perseverance rover, will not be able to do that if if it is just go straight up, because every time it need to fight with the gravity, and that will reduce its efficiency and increase the gravity losses. Oh yeah, that was a good reason and clever engineering at its best. Rocket engineering is always rocket, not only rocket, the space technology itself is very basic and very clever at times, because anytime you design anything, whether be it satellite or rocket, you need to deal with new problems which have not been solved. I mean, yes, the principles remain the same, but how you are designing the, let's say for the rockets have been designed for so long, and we know how to design the rockets as such, but still every rocket design is different from the other, because you are dealing with challenges which kind of appear at that point of time when you are designing the rocket. That may not be the case for other rockets, like for this one. You can see the flight sequence, how does that happen, and they would have run some great simulations and numbers to see that that maneuver does not basically break the rocket or the satellite. Yes. And talking about someone mentioned about the camera angle, if mode lust for IR, yes, that could be the case, but I don't think so that camera angle was um, was that camera angle thing happened there. I don't think so. That was a pitch down maneuver intentional. And wow, look at that animation right now. It is spinning, as she said, to it is doing the barbecue maneuver basically to basically toast the satellite in all the directions so that it does not get hidden up in just one direction. You kind of say that. So, yep.
What the throughput is, when people are parking, when people are using the supermarkets, and then you can sell that to companies to target promotions, for example, to those people when they're there. So lots and lots of applications. And it's particularly important, of course, with the driverless cars, because they need to know exactly where they are. Super accurate navigation needs two things. It needs satellite positioning, but it also needs very precise maps. And the accuracy of Pléiades Neo is going to be extremely helpful in geolocation. Another interesting application actually is monitoring storage cylinders for oil. As you know, they have floating roofs, and the satellites can detect the changing shadow of the roof as the oil goes down. So you can calculate the volume of the oil inside, and that helps to know where
Wow.
the oil supplies are in the world, and it can be useful for economic forecasting of the oil in the barrels. All kinds of applications. Water is another one. Pléiades Neo is going to be able to see several meters down into the water, and that's going to be very useful for example, looking for plastics and
Not
pollution.
no, Scott. I was actually kind of
The
doing a
list goes
quiz.
on. There are so many applications, and so many people are going to want to use it. And in fact, anybody can access these images. You don't have to be a government or an NGO. Absolutely anyone can access the images. Airbus have an online platform. It's called One Atlas, and all you have to do is log in and choose what you want from their archive. Or else you could also task the satellite to collect new imagery.
A high resolution public satellite. Well,
All
that is
satellites, however
actually,
big and small,
uh,
are
a thing
products of
which
passion,
countries won't like
creativity, and
because,
expertise.
of
And
the
you don't
border
have to
issues
be an
and
engineer to
everything.
work in
It is a very
space.
high
There are lots of
resolution. I
different
don't know
jobs.
how much
And there are
resolution is
two people
allocated
from
for the
Airbus to
public.
tell us about
I
their
am
job. Let's
guessing
watch
that
the
it is
film.
the resolution which will be available public will not be 30 centimeters. I guess. I am not sure about it, but
On s'est
yes.
jamais rencontrés, c'est la première fois.
Airbus, c'est une grande entreprise, effectivement. On a toujours l'occasion de rencontrer quelqu'un de nouveau. On
You can
appelle ça la
say
GX.
like
Ça fait combien de
Airbus
temps que
is
je travaille
kind of
chez Airbus depuis
Lockheed
l'aérospatiale
Martin for
depuis 37 ans.
Je
Europe,
m'appelle Mine,
Europe.
j'ai 37 ans. Je travaille chez
That is it.
Airbus depuis environ 13 ans. Je suis plutôt en en fin de chaîne. Toi, tu es plutôt au début, dans la conception.
Je suis architecte système du segment sol. C'est la partie du système qui est localisée au sol par opposition à la partie du système qui va sortir de l'atmosphère. Et donc architecte système, c'est la personne qui est en charge de comprendre le besoin. Souvent le client veut se doter d'un système spatial, mais pourquoi faire ? Et quand on nous dit que ça marche, quoi, une fois que le satellite est lancé et qu'on a des premières communications avec le sol et qu'on voit que ces données-là se transforment en une image, quoi. Et Nelly, si je comprends bien, dans l'exploitation, une fois que le programme est terminé, enfin que le système est livré, collecte d'images, programmation d'images.
Je vais utiliser son système. Le métier de tasking spécialiste, c'est opérer les satellites, c'est gérer les acquisitions des satellites. Un client a besoin d'une image, on va faire en sorte qu'il ait l'image dont il a besoin. Il faut être débrouillard, savoir bien communiquer. Pour pouvoir acquérir les images dans le temps imparti et acquérir de bonnes images, il faut prendre en compte tout un tas de contraintes. Il peut y avoir plusieurs clients au même endroit qui veulent la même image ou le même secteur. Il peut y avoir des contraintes météorologiques et il faut prendre en compte tout ça. Et donc c'est un peu comme un jeu de logique.
L'organisation, le relationnel et la curiosité. C'est un métier d'ingénierie sur lequel on ne peut pas aboutir si on n'a pas la curiosité de savoir ce que veut notre client, de savoir comment fonctionne notre sous-traitant, de savoir à quoi va servir notre système. Ma phase astronaute, on va dire. Et par la suite, elle a fait que croître. Alors maintenant, bon, le rêve de devenir astronaute est resté dans le passé. Petit à petit, je me suis aperçu que toute cette histoire qui s'est écrite autour du spatial, en fait, elle avait un point commun qui était l'excellence, la recherche de l'excellence dans tous les programmes. C'est ce qui m'a motivé une fois que j'ai eu mon diplôme d'ingénieur en poche.
Alors non, pas du tout. C'était pas un rêve d'enfance. Je suis arrivée dans le domaine du spatial complètement par hasard. J'ai fait une licence de géographie. Ensuite, je me suis spécialisée dans les systèmes d'information géographique et j'ai été recrutée pour travailler sur un projet de cartographie. De fil en aiguille, je suis arrivée dans l'équipe tasking, donc directement en lien avec les satellites.
Mais ça suffit pour faire naître une passion, hein,
oui, je suis très contente. À la base, c'était pas ce qui est prévu. Je voulais être hôtesse de l'air ou prof de danse, alors bon.
Et souvent, le spatial, on pense à des ingénieurs derrière des tableaux noirs qui écrivent des équations monumentales et affreuses. Mais il y a 1000 façons d'arriver à poser sa sur un programme spatial.
Yes.
Les missions. Quand on part chez les clients à l'étranger, parce que c'est des clients qui ont leur propre infrastructure, leur propre antenne et reçoivent les images directement chez eux. Nous, en tant qu'équipe tasking, on part pour les former à utiliser nos systèmes. Et quand on les rencontre la première fois, ça fait toujours quelque chose. Dans l'équipe tasking, on est divisé en petites zones géographiques. Moi, j'ai surtout voyagé dans la zone du Moyen-Orient. Je suis partie au Qatar, je suis partie en Azerbaïdjan, en Turquie. Mais c'est bien, ça permet de grandir dans son métier, de prendre confiance en soi et de se dépasser.
Il y a quelque chose qui m'est arrivé récemment que j'ai vraiment adoré. C'est une photo montrant que mon nom avait été marqué sur la coiffe du satellite, enfin la coiffe de la fusée qui a embarqué le satellite. Juste mon nom qui est parti dans l'espace. Je trouve ça extraordinaire.
Moi, ce qui me motive là, dans les années à venir, c'est qu'avec le lancement de ces nouveaux satellites, on va aller chercher de nouveaux clients, et notamment de nouveaux clients à l'étranger pour avoir de nouvelles stations. Et il va y avoir tout un travail de formation et de visite aux clients, et de nouveaux process à mettre en place. Je suis assez motivée en fait par ce challenge.
Le spatial est en train de régénérer du rêve dans le domaine de la recherche des exoplanètes. J'ai le sentiment comme ça qu'il y a un morceau de l'humanité qui attend à se dévoiler avec un jour l'annonce du fait que oui, ça y est, on pense pouvoir affirmer que la vie existe sur telle ou telle planète.
J'espère que notre métier est un métier d'avenir. Notre force, c'est notre savoir-faire.
Je pense que l'observation de la Terre aujourd'hui, avec les enjeux climatiques, ça devient vraiment le moyen d'avoir des informations à la bonne échelle. Il semblerait qu'il y ait des problèmes au Canada, des problèmes en Europe, des problèmes en Australie. Et je pense qu'une vision locale, une interprétation locale de la situation n'est pas suffisante. Donc je pense que l'enjeu de disposer de bonnes informations acquises à la bonne échelle, donc des images satellitaires, vraisemblablement une clé de la réussite de la résolution de nos problèmes de le climat.
Okay.
Very inspiring to hear all that, particularly if you're a young person looking for a job in space. So let's have a little recap. We're flying through space. We are coming up to 35 minutes into the launch of our 5 passengers. And we lifted off from the pad just under 35 minutes ago. Let's take a look at a replay of our launch.
Yes, we all want to relive that moment. So
It was a very spectacular launch, actually. We're looking at the Mission Control Center here, and the teams there. This is what it looked like. We lifted off from the pad
Wow.
at the Guiana Space Center on the northeastern coast of South America, lighting up the night sky. And the birds flying across the frame there. And our satellites went up inside that fairing. 5 passengers, Pléiades Neo. We've talked a bit about Pléiades Neo, but let's turn our attention now to our other 4 passengers. They're all babies, but in size only, I can assure you, they are CubeSats. And as I mentioned earlier, they're made of 10-centimeter boxes. And that's very important because they're cost-effective.
We're getting different camera angles, which is great.
And they can offer unique opportunities for businesses. That was a superb launch, wasn't it? Look, we tucked in behind the clouds, but we came out the other side and we got some really, really good views. So, on
Separation,
board,
the
we
retro rockets
have
firing, and then the ignition. Wow.
Bro 4 for a company called Unseen Labs. It's made of 6 units, and Bro 4 is the 4th in their constellation for intercepting radio frequency signals from space. Now this is going to allow Unseen Labs to geolocate ships at sea using its own onboard technology to identify electromagnetic signals from vessels. So it's going to be very useful for the maritime industry. Our 3 other satellites are for the European Space Agency. We've got one called LEDSat. It's made of 1 cube, so that's probably our smallest satellite on board, and it's an educational project with ESA's Fly Your Satellite program to help university students build, test and launch their own CubeSats. And LEDSat was developed by the University of Sapienza, I should say, in Italy, and this is the 2nd time that we have launched a satellite for them. LEDSat is going to investigate the performance of LED-based technology, so light-emitting diodes, and that's to identify and track satellites in orbit. So again, very, very important work, and huge congratulations to all the students getting your satellites ready and on its way. It must be very exciting for you guys to have seen it lift off from the pad. So we also have Sunstorm. Now these are 2 satellites which are dedicated to space weather. Sunstorm is a 2-unit CubeSat. It was manufactured by Finland's Reactor Space Lab. It's going to detect the X-ray pulses produced by coronal mass ejections. Coronal mass ejections are the massive eruptions of material that come off the sun's surface. And they can be harmful, actually, to satellites and to things like terrestrial power and communications networks. So it's very important to monitor them, and that's what's happening there. This is important work. RadCube is a mission by an international consortium to demonstrate miniaturized instruments that measure space radiation in situ and the magnetic field environment in low Earth orbit. Now, I mentioned the coronal mass ejections traveling across space and bombarding everything in their way, and this is called, as I said, space weather. And RadCube is going to establish a system to provide space weather forecasts for companies and organizations like telecoms, for example, or energy, or spacecraft. And the platform developed by C3S is also going to be demonstrated in flight. So we have 4 really special satellites there alongside, hitching
Yes,
around
I
alongside.
must admit that they are actually flying some very interesting satellites. Okay, Breed says you should do a launch recap ASMR. Oh, okay. Well, that sound kind of a
11:36
doable thing, but I want
Kourou,
it
and that's
because
4:37
I don't
in the
know whether
morning
it
here in
will be,
Paris and
good to
elsewhere.
do, or
It
it
was
will it be
definitely
a cringy stuff to do. So right now everything is so finally we are saying that it is out of telemetry phase, and people wondering why is it still attached AVUM stage. The reason being, sometimes the reason is the visibility, the sometimes is it is actually the telemetry. I mean, the ground station, most of the time it is the ground station that it is that the satellite has to work with is not present at that moment of time. It holds up with the satellite for certain time, and then finally it detaches it. So right now what you are seeing is waiting for the ground station to come, and then they will detach the stage, the satellite, basically. So that's how the things work out there, and everything right now is looking great. So what else do we have? See? Yes, sometimes it does not detach the um, satellite because there are certain conditions where it has to detach it in sun position or what. There are certain conditions sometimes which play, but most of the time it is the ground station interferes. That's why it has to catch it when there is a ground station to catch the signal from the satellite. Yes, the blackout period. Right now they are in the blackout period only, and once they have the station, the satellite, they will be able to detach it. And again, this is the main customer which they will be detaching it first, the bigger satellite which you can see on the stage, and then we have these 4 CubeSats also flying. So, yep. They have purchased the onboard cameras also, but we are not seeing those things here, which is evident only. And the animations are great. I must say that. Whatever you want to say, you can, but the animations are actually great. Some you can say uh, they are in competition with the Soyuz and Soyuz basically. Yeah, Soyuz animation. I would say the animations are even better than Soyuz. In the meantime, guys, if you have anything, you can ask me. Soyuz is getting so old, they really need to try and work placement. Yes, it is going old, getting old. It is from the family of the rockets, which I think is the oldest one right now. And they are working on the replacement also. Soyuz 6 or Soyuz. I'm, but yes, they are working on the upgraded version of the Soyuz. Soyuz is definitely very old, but it does job, and it is still very efficient, and it is still in the play, which we can see that Arianespace also has acquired the Soyuz contract. So not only Russia is launching Soyuz, but even Arianespace is launching Soyuz. So Soyuz is in demand now also. It has not kind of gone into um, not existence, but yes. What When is the next launch? or what is the next? The next launch would be most probably the I say the Chinese launch, but again the Chinese won't provide us with the live stream, so let's not count that. It was supposed to be the Starliner launch on 19th of August, but again that whatever has happened, so it has been delayed indefinitely, and probably will not be launched this year itself. So Starliner is getting those curse on it. But if we see this thing like they detected this valve issue after the Nyoka incident. Nyoka incident caused the Starliner to delay its launch, and finally they detected the issue with the valves. What if they launched the rocket on the designated date if it was not for the Nyoka module, and again was it actually resulted into a failure? That would not be very good, because uh, previously also there was some issue with the software and the which caused the engine to underperform, and it finally didn't achieve that rendezvous orbit, had to uh, deorbit and then land back to the earth. The second mission was successful for landing, re-entry and the landing, but again the main primary mission is to dock with the ISS, was not successful. So yes. Okay, talking about the next one will be the OneWeb mission then on 20th August. And OneWeb mission, again the Soyuz will be launching the OneWeb mission, and is also aiming for the launch in August only. Their 3.0 rocket, and hopefully we will be getting the live stream of this thing. Let's hope, because they have already achieved this orbit the first time, and now they should, let's hope we get some live stream out of it. And then the SpaceX with their CRS 2 mission will be launching on 28th August. So Electron is also planned. The Firefly, I don't know what happened with the Firefly. They were so close to the launch. They were supposed to launch in mid March 2021, and then they slipped and slipped and slipped, and no update on their side as in what is happening there. But they are aiming for this window again. I don't know whether we will be seeing their flight anytime soon. So yep, that is the case right now. There are a few fluid problems on Starliners. I won't say fluid, but the valves problem on Starliner. Yeah. What should I say? Fluids or valves? Valves or fluids? Right now, they say that it's a valve problem on the reaction control system, which is a big issue, because if they would have launched with that issue persisting, that would mean the attitude control system would not work properly, and again they will obviously attitude control system is the must when it comes to the docking, and obviously then again they won't be docking to the ISS, and that would result into a failure of the mission. Yep, that is what is happening. Boeing should have partnered with the SMC and never made that Starliner. Uh, what should I say? Starliner is kind of necessary to do the missions to ISS with utmost redundancy. Starliner is not. You can say Starliner is in existence to achieve the redundancy in flying to space station, because right now we only have the SpaceX doing its job, and if for any reason whatsoever, whether there is a delay with the production, can't happen, is a which has a very very rare chance, but if there is a delay because the rocket had some malfunction or whatever, so they do not have to wait for um, uh, um, the Soyuz again. They do not have to rely on the Soyuz to launch the
Five
rocket. They
passengers.
can be self-reliable. So that's why Starliner came into existence basically.
That was 49 minutes and 23 seconds ago. We lifted off from the pad at the Guiana Space Center.
Infinity
10:47
had
at
fluid
night, local
problem.
time in Kourou. That was 1:47 universal time. And we went hurtling into the night sky on board a Vega rocket, lighting up the skies over the spaceport, which is right. So we're heading out over the sea here. We've got a great view of the launch, and now this is what it looks like up there in space. We have our Pléiades Neo satellite attached and our other 4 auxiliary passengers attached to the upper stage. It's called the AVUM or AVUM upper stage. Our auxiliary passengers are in those little boxes that you can see attached to the adapter. They're the deployers. They'll come out of those. But first of all, before that can happen, the Pléiades Neo satellite needs to be released onto its orbit. We've been traveling outside the range of the tracking stations, and soon we're expecting to come into the range of the new Norcia station. There's our flight path. We've been traveling north to south. We lifted off from...
Acquisition de télévision pour la station de New Norcia.
And we've got confirmation there that we've picked up the signal in the New Norcia tracking station. And you can see our telemetry details have come back on the bottom of the screen. And we're traveling there at a speed, vitesse, of 7.55 kilometers. We're at an altitude now of 619 kilometers, and that's where we need to be to release our first satellite. We've crossed the planet. We've done nearly, I think it says 18, nearly just over 18,000 kilometers. If we were to draw a straight line along the Earth, we've traveled that distance, so it's pretty impressive. Flying now over, or heading out towards the south, the west of Australia. And he's telling us that everything's normal. So we will have downloaded a lot of information from the AVUM upper stage to the tracking station in New Norcia. That information helping the teams at the Guiana Space Center, the telemetry teams, or the CVI as it's known there, to give us this telemetry in real time and let us know how things are going in real time. They then pass the information on to the range operations manager, who calls it out. Next phase will be the switching on of the upper stage. It's getting ready to switch its engines on now, back in the pre-burn phase that we saw before. There we have confirmation there that the upper stage AVUM has switched its engine on, and it's now going through an orientation maneuver, as you can see there. It's quite impressive watching it. Quite impressive watching it all. It all looks like everything's happening in slow motion, but the truth is we're hurtling along at just under 8 kilometers, 7.5 kilometers per second. Let me just drive that home for anyone who's never seen a launch before. Not per hour. And we've climbed now to 623 kilometers altitude. Look at the line of our atmosphere, the blue line of our atmosphere on the edge of the planet. That's what's protecting us and keeping us safe, and we need to keep it safe. Upper stage, performing orientation maneuvers. We have to position the satellite incredibly precisely into space. It needs to be orientated to a very specific set of procedures. All this has been incredibly carefully planned. It's quite beautiful to watch. You can see why some people like to call this the space ballet.
Okay, so
That's what it looks like up
John
there,
Wilson says,
with
if you
AVUM
don't mind, would you like to
moving the
tell the
satellite
audience
into
about your other
position
interest space? For
so that we
example,
can then get
yeah,
ready to
Perseid's
separate
Peak.
the Pléiades Neo
Um,
satellite.
Fine.
Séparation Pléiades Neo 4.
Okay, we have
And
the
we have
separation
confirmation.
of the
The
satellite
Pléiades Neo satellite
confirmed.
has been separated.
Mission accomplished successfully.
Very happy faces in the Mission Control Center. People have worked for many years for this. It's a big moment. A wonderful moment. And of course, it's the end of the job for some and the beginning for others, because we have
To
the
track
teams
the
on the ground
satellite.
who are taking
Exactly.
charge of their new baby. And they need to be concentrating very hard right now because they are operating their satellite. And of course, they'll be waiting for Neo to call home. The team there and the flight directorate all looking very happy. JPE, I wonder what that means.
Okay. Yes, I do
So we
follow
saw
those meteor
Pléiades Neo
showers,
there
John
moving
Wilson, and
away gracefully
I
from the
basically,
mothership.
like to read
A
about
set
this
of
stuff
screens moving it
happening
away,
in space,
and we
as in a whole.
have 4 satellites
Basically, I'm
attached, of
not, you can
course.
say,
Our
totally into
passengers, they're
astronomy,
going to be
but whenever
booting
some
about
big
50
discovery happens, I
minutes
do
from
like to read
now.
about it.
Their separation
And
will
whenever I
start at
read about
around
it, I do,
44 minutes
read
after
about different
launch.
things associated with it. So,
I think we might
that
be
is one
invited to have a
thing.
look at some
Other
replays
thing
here.
is, which
This is what
I
it all
do
looked
like
like
to
right
read
at the
is
beginning,
about is the
just
space
6 minutes
technology,
ago,
because
lifting off from the
uh,
pad.
whenever we I must say
So
that we
our
take space
4
technology for
satellites,
granted.
just a
I must say
reminder, they
that
are
that is
red
so
sat from
complex and so
Sunstorm. They're going to be
cleverly
first.
engineered piece of hardware
Then
which goes
Row
into
4 will be
space that,
released.
wow, if you read about it,
Row
you will
4
be
has
very amazed, like how are they designed, how are they tested, and finally what are the criteria. Like
They're
even for
followed by
this
Radar,
satellite,
which will
they have
be
a gold
ready
foil, gold
afterwards.
something coating on the satellite. Can you tell me the
Watch
reason
all
for
that
that?
because we're going to leave our live stream up for you. We're going to leave our
So
CGI images,
there is
and we're also
there
going
are
to leave the French
certain
operations and the
reasons for
British
having
operations
these
listed
gold
here. And
colored
we're going to leave
satellites
all
to
the
space.
telemetry information for you on the screen so you can follow the launch on the screen. Or you can also uh, keep track of our social media websites, and we'll keep you posted on our Twitter account. You can get all the confirmations of the separations and all the information.
Fine.
So, good luck to everybody for the release of your satellites, and congratulations to Airbus Defence and Space. I hope everybody feels proud of themselves. It's a job well done. Very best wishes to all the teams involved in today's mission. I'm going to cut my mic off now and say goodbye. So from me, Katie Haswell, and our interpreters, and from everybody who's bringing you this live webcast, until next time, goodbye.
Wow. See those graphics. These are actually the best graphics that I've ever seen. Yes, it is better than Roscosmos. I must admit that. Wow, just look at this thing. They even include those sun glares and everything. So, uh, happened here. Am I audible? Don't know whether am I audible or not. The stream is running or not. Check. Yes, the stream is running. But my PC has this black screen right now. Everything is looking good on the front, but my screen is running, and I guess, oh, not looking good. I must restart my system then, because I don't know what happened here and I just lost the control. You can hear me. Okay, guys, just bear with me. I'll just quickly restart the system, and on this, um, you will find the live stream on this stream only, so don't go anywhere. There may be a little bit of buffering, but I'll be back. Just hang on a bit. Okay, there is something which is very weird here.
Troisième allumage de l'AVUM.
Back now. Okay, we have an AVUM ignition here. You can see that.
Extinction de l'AVUM.
Yes, I'm back. Okay. Cool. So we do have an sorry for the hiccup here. I don't know what happened with my PC. Just behaving a bit oddly for some days, but okay, I'm back. Thanks for waiting, whoever waited. And right now we just witnessed one AVUM ignition and shutdown. Everything is looking good, and yep, we do still have some time for those CubeSat separation, but I don't think so we'll be seeing this stream all day now. Let's move on to our ritual, which we do after so this thing, because I want to discuss something which we should be discussing here. So, talking about first of all today's stream, Arianespace, you nailed it, literally nailed it. That's what we demanded for. Now, not only you just what should I say, spent less money, but you even what should I say, made your stream coverage better, because all those money gone for having all those space commentators and everything is, I don't think so, is worth it. So you did the right job today, and yep, this is the thing which I had to talk about. Hopefully this will come up in stream also. This was very cool. Yes, exactly. Yeah, there you go. Okay, lead engineer of Blue Origin's team has left the company,
Attendu de la
and there
télémesure.
is a big reason for that. Just see this thing. So, guys, what has happened
Grève de
here?
la télémesure
Uh,
encore pour environ 39.
Here, actually, Blue Origin has literally sued NASA over the HLS contract. They have filed for a lawsuit against NASA, and I don't know why, but I think they are being selfish this time, because not only they are suing NASA for not giving them the contract, but also they are delaying the Artemis program, which will be like a huge problem for NASA itself, because right now it is already delayed, and further delay would mean that uh, we are not getting back to the moon anytime soon. And they did it. They literally did it. And right now you can see the lead engineer for Blue Origin, Nitin Arora. He has left on Friday, the August 13th. It was his last day at Blue Origin. It was one hell of a ride working on lunar program. Really honored that I got a chance to work with and lead incredibly smart, passionate people over the last 3 years. Special thanks to everyone who I worked with, and I will see you all next stop SpaceX. I'm incredibly excited and looking forward to it. See, this is what happens when you have those upper people who are literally, you know, uh, doing their tactics which their employees don't like, and there is a toxic work culture which is created, which causes incredibly talented people to just resign from their job and find a different one. Yes, I guess you need to, if you are having some blur issue, you need to check your uh, resolution, I guess, because right now I'm streaming at 1080p. Yes, yeah, that is one thing. And yes, they did a great job for today's. Okay, what I meant was I actually shared that. There you go. Jeff Bezos' Blue Origin has sued NASA, dragging its flight to win a chunk of lunar landing funding into a new phase that could trigger another lengthy pause to SpaceX contract. Not only the SpaceX contract, but the Artemis program as a whole, because now NASA would be busy dealing with the lawsuits and everything. And I know space, the engineers and scientists won't be. They have their NASA have their uh, lawyers and all, but again, there could be delay with the funding space program, uh, or maybe just because of this delay, we know how the courts work, and we don't even know whether this will allow Artemis to fly now. We don't know what will happen in next, because court lawsuits are not good at all. They get stretched for years and years, and we don't get a result. I don't know what will happen this time. Blue Origin, Jeff Bezos he has his own company. He's a billionaire. We like 189, $98 billion right now, and he can literally launch its own space program. If he is so much into getting its lunar lander done, he can literally do it on his own. He don't even need NASA to give him the contract. Maybe if NASA is doubting their potential, so he can just prove them by launching one of those lunar landers and everything space, and demonstrating this. Because first of all, the first lunar lander obviously will be without humans, because you have to demonstrate the ability. So you can do that without having NASA giving you the contract. If once you do that, and NASA also, since now it is in operation, they have accomplished that, and then NASA would not hesitate for giving them to contract. Basically, don't know what has happened here. Real bad from Blue Origin for management, must say that. Blue Origin is reminding things that they have absolutely no experience with. It's like a child outside a toy store on the time because they wanted to. Absolutely, exactly. But I would say they know. Blue Origin does not know what they are doing with the lunar lander, but the, the Blue Origin actually had the national team with it, the Lockheed Martin and and all those things. ULA was also a part of it, and they do know their job. So I won't say they were completely out of experience, but again, the main contractor for that was Blue Origin, and Blue Origin, you can say, kind of was established. For why are they going in for this lunar lander mission contract? Why are they so desperate about this? Because Blue Origin was kind of, you can say, uh, established, or you can say had this goal in mind to have some involvement in lunar missions. We have seen the presentation of Jeff Bezos way long back when he the lunar lander. They were working on it, and Blue Origin, as you know, is already way behind its schedule for delivering the engines to Tory or making New Glenn. And this lunar lander contract was them. They were working for it for so long. Maybe that may have pissed them off. I don't know, but again, the company which you are talking about is Blue Origin. The owner is Jeff Bezos. They can literally launch their own lunar lander without NASA giving them the money. That's it. That's the thing. They give ULA the engines, the BE4 engines. If you can't make New Glenn at that point of time, give the ULA those engines, and they can surely deliver the lander modules, the 3 launches needed for it. Absolutely, they can do it in with the Vulcan, but you have to give the engines to Tori. I don't know what is happening right now. Vulcan is in testing, and we should be seeing some activity related to Vulcan testing also. But the engines which will be there on Vulcan will be the BE4 test engines, not the flight engine. So I am very sad. I feel very sad for Tori, because he has limited number of RD engines left for Atlas 5, as the contract has ended, and the Vulcan is just getting delayed and delayed, and they have to demonstrate the smart reusability also, wherein they reuse the engines, which is very necessary in this case, because what we can see from the delay. So yeah. Okay, what else is there? The sunstorm. Discuss about. And yes, the situation in Afghanistan. What should I say? My heart goes out to all those Afghanistan people. I mean, the situation is real bad, but it was evident. It was evident. Must say that. Uh, it was supposed to happen today or tomorrow. There was not a fixed date. Was supposed to happen. They have the earthquake also has hit. Wow. Okay. It was supposed to happen now or whenever the troops had to retreat. They had no option but to had to retreat. Maybe they could have strayed. People would argue that I won't, take any political stance on it. But if you ask me logically, there was no reason for USA to stay in Afghanistan now. So I won't say that they did right or wrong. I won't comment on that. But it was evident, and they trained Afghanistani people. Afghanistan 100,000. Don't know what went wrong then. Just don't know. But my heart goes out to all those people out there. So okay, let's get back to this. That's a hot note. Okay. So what they did was, did you know what they did was here? You can see the rocket powered tooth removal.
I'm going to launch my tooth out with a rocket.
Okay, you ready?
Yep.
Okay. Look at me and tell me what you're doing.
I'm going to launch my tooth out with a rocket.
Can you hear him? Yeah. He said, I'm trying to remove my tooth with the rocket. This is literally those things which the dad do with their children. That's why that meme which we have, don't leave your children with the dad. Literally, he's removing the tooth of his child with the rocket. This is very cute and awesome and dangerous also.
Look at me and tell me what you're doing.
I'm going to launch my tooth out with a rocket.
Literally, they are trying to do that. You can see it here, and the actual launch, the tooth is long gone. Okay, what happened here?
3, 2, 1. Nope.
The rocket launched.
3.
I don't know what happened to the
2,
tooth.
1.
Maybe has launched before only, but don't try this at home. This is actually dangerous. He said that everything went fine. I don't know either he meant sarcastically or what. He even did it or not. But don't do this to your child. It is very dangerous. That thrust of it could literally pull all of the things out, not only the tooth. So careful with that. Don't do this. No matter how big fan you are of those rockets and everything. Okay, so I guess now we can end the stream with this thing. And thank you so much for joining in. What else do we have? Nothing. Right now, nothing. And the next stream would be hopefully will be the Soyuz launch of the OneWeb and the Soyuz launch of the OneWeb. If we don't get any footage for the Chinese space agency, which I'm not expecting at all. So yeah, OneWeb would be our next stop on 20th August. 3 days from now, and we will be coming back with the streams for you. So Thank you so much for all for joining in. And if you like this stream, you can give it a like. 104 likes, cool. And if you want, you can become a member of this channel. This really will help me get a sustained income for this one and let this channel run for more longer. I mean, I really want to, just do my stuff. I don't want finances to come in between, but this is reality of life. Sometimes you need to, you know, have those finances also flowing for what the work you do, because otherwise people question, and sometimes the time also which we invest, you know, is the thing which have to look out for. So yeah, thank you so much all guys for tuning in, and I really appreciate your support. You guys are great, and I always forget to thank my Patreons, all my Patreons right now, and the YouTube members. Thank you all for being so awesome, for supporting my you know work, and you guys are great. You guys are awesome. We'll see you back with another stream. And until then, this is Pianshu Roila. You just saw Rocket Gyan. Stay safe, stay healthy, and